recent years, the field of industry and production economics has seen a significant shift towards innovative methodologies in value chain practices. The utilization of advanced analytical techniques has enabled researchers to delve deeper into the complexities of supply chains, manufacturing processes, and organizational structures. This article aims to explore various methodologies that have been instrumental in driving innovation within industry value chains, highlighting how these methods have been applied to enhance understanding and foster improvement in various sectors. Structural equation modeling emerges as a pivotal tool in this arena. This statistical methodology allows for the exploration of complex relationships among variables, both observed and latent. Its ability to incorporate multiple variables and their interconnections has rendered it invaluable across diverse research domains. For example, SEAM has been utilized to evaluate key performance indicators in healthcare logistics, analyze the effects of production technologies on environmental and financial performance in manufacturing, and explore barriers and strategies for Industry 5.0 implementation in emerging economies. Moreover, it has been pivotal in validating theoretical models in supply chain innovation, particularly under the paradigms of Industry 4.0 and 5.0, and in assessing the impact of supply chain digitalization on resilience and performance. Exploratory Factor Analysis (FA), another significant statistical technique, has been widely used to uncover underlying variables that explain correlations within a set of observed variables. This method has been effectively employed in developing Industry 4.0 readiness models, reshaping sustainable value chain models, examining green supply chains, and understanding the role of contractual and relational governance in digital traceability in food supply chains. FA's ability to identify relationships among a large set of variables has made it a go-to approach for researchers seeking to understand the underlying structure of complex data sets. The fuzzy synthetic method, SIM, represents a decision-making technique that blends fuzzy logic with synthetic analysis. This method has been applied in conjunction with other methodologies to tackle complex problems, particularly in the context of sustainability and circular economy. Researchers have used FSM to explore sustainable value chain models in the fast fashion industry post-pandemic, examine remanufacturing modes and strategic decision-making, and address technology transfer in high-tech firms. Social network analysis, a methodological framework for analyzing social structures through networks and graph theory. It has been adapted in various fields, including supply chain research, to understand the impact of different parts of a system on each other and the benefits arising from interconnected relationships. Researchers have applied SNAR in several contexts, such as analyzing green innovation output in supply chain networks and exploring competition dynamics in the IT industry. Stochastic frontier analysis was a statistical approach used to measure efficiency and productivity. This method has been employed in studies analyzing productive efficiency and operational improvement in various contexts, including the impact of certification on productive efficiency and the role of digital transformation practices in manufacturing. The best-worst method, PRIM, is a multi-criteria decision-making approach that involves evaluating and ranking various factors or criteria based on their relative importance. This method has been utilized in studies focusing on the adoption of quality standards for corporate greenhouse gas inventories and developing probabilistic decision-making models for sustainable supplier selection. The augmented epsilon constraint method, AugMaCAN, is applied in solving complex location inventory routing problems within circular closed-loop supply chain networks. This method is particularly relevant for industries integrating sustainability and circular economy principles into their operations. Qualitative data analysis, QTA, is an essential research technique employed to interpret and understand data that are not quantifiable in nature. This approach allows for a deeper insight into human behaviors, opinions, and experiences, as demonstrated in various studies, including developing resilience in healthcare during pandemics and exploring circular business models in the apparel industry. Text analysis method has been increasingly employed to explore various aspects of manufacturing and organizational resilience. This approach involves analyzing large volumes of textual data from authoritative sources such as annual reports, research articles, or other relevant documents to extract meaningful insights and patterns.